Hi, guys. Today we're on Unit 12, Lesson 2. We're going to be learning the product rule. But before we begin, we're going to just review some stuff from before break. Okay, so we're going to talk about some of the rules we already know how to use. Okay, so before break, we talked about this power rule, right? If we take the derivative of something times a variable raised to a power, bring the power down in front, multiply it by whatever number was there, subtract 1 to get the new power. Okay, we just want to remember that when we use this rule, we want to rewrite negative powers and radical signs. Okay, we're going to review that in just a minute. Okay, we also learned the basic trig derivative rules. The derivative of the sine is the cosine. The derivative of the cosine is negative sine. So just a few quick problems before we actually move on to the lesson. Differentiate, find the derivative. So if f of x equals 3x to the fourth minus 5x cubed plus 2x squared minus 6x plus 8, to take the derivative, we go term by term. 12x cubed minus 15x squared plus 4x minus 6. Remember, when it's just a plain old x, it's just the number out in front. And then the 8 just becomes a 0, so we don't even bother with it. Okay, and just to remind you, this saves you the trouble of doing the definition of the derivative once we know these rules. If f of x equals 4x to the negative 2 plus 7x to the negative 1 plus 2, term by term, apply your rules. Negative 8x to the negative third minus 7x to the negative 2, and the 2 just becomes a 0. We can rewrite this with positive exponents if needed. You should know how to do this. And that's your answer. If y equals 2 rad x plus 3 times the cubed root of x squared, we have to rewrite this function. So we're going to 2x to the 1/2 plus 3x to the 2/3. Now, when we take the derivative, y prime, bring our power down in front, 1/2 times 2 is just 1. Subtract 1, x to the negative 1/2. Plus, bring the power down in front, 2/3 times 3 is 2. 2/3 minus 1 is negative 1/3. 1 over square root of x plus 2 over the cubed root of x. So pretty easy stuff here. If y equals 3 times the sine of x plus cosine x, then y prime is simply 3 cos x plus negative sine x. And remember, every time we find the derivative, it's a rule to find the slope of the tangent line to the original function at any given x value. Okay, that's what this rule represents. So that was just a little bit of a review to get us back in the swing of things for today's lesson. So today we're going to be talking about something called the product rule. And we're going to begin with this do now. If f of x equals 2x minus 3 times x squared minus 2x plus 1, find f prime of x. Okay. Right now, the only way we can find f prime of x is by distributing this out. So we have to distribute. So I have to rewrite this function, 2x cubed minus 4x squared plus 2x. Right now I'm going to do this term to each of them. Minus 3x squared plus 6x minus 3. I'll clean this guy up. 2x cubed minus 4x squared minus 3x squared, 2x and 6x. Now that I've got this function rewritten, now I can take the derivative. So f prime of x is equal to 6x squared minus 14x plus 8. So today we're just going to learn another derivative rule. This rule is going to be the product rule. We're going to use the product rule if we have two functions being multiplied together. So today we're going to talk about another rule that we can use in this type of situation. So for instance, the product rule states, if P of x equals f of x times g of x, actually, we'll do this in a different color, right? If I have two functions there, then the product rule, then the derivative is P prime of x is the first f of x times g prime of x plus g of x times f prime of x. Now remember, this rule was gotten. I could derive it using the definition of the derivative, but it's very, very complicated. So we're just going to say, memorize this rule. The easiest way to memorize this is in words. Okay, so whenever I'm using the product rule, I always kind of talk to myself in my head. The first times the derivative of the second plus the second times the derivative of the first. First times the derivative of the second plus the second times the derivative of the first. Any rule we already know can now be combined with the product rule. Let's redo the do now using the product rule this time. So if f of x equals 2x minus 3 times x squared minus 2x plus 1, this is your f of x, this is your g of x. The first times the derivative of the second plus the second function times the derivative of the first. Okay. Now, in this case, we're not done because now we have to clean up what's left. So now I'm going to FOIL out. So I have 4x squared minus 4x minus 6x plus 6. 2x squared minus 4x plus 2. And hopefully, if I did my math right, I'm going to wind up with the same answer as I did up top. 4x squared and 2x squared, 6x squared. Negative 10x, negative 4x. 6 and 2. And let's just stop a moment and see and compare. And we got the same exact answer. Okay. Now, here's where you have to decide. Okay. It's not always necessary to use the product rule when you're finding the derivative of two functions if they're both algebraic. Okay. Always think about what you're doing before you start a problem. In this case, I think it would be easier to FOIL first and then take the derivative. Okay, so these are the things we're going to talk about as we move through the rest of this unit. Some practice questions now. So if f of x equals x squared times negative 3x squared minus 2, again, I would probably clean this up first. Negative 3x to the fourth minus 2x squared. You don't, just because we know the product rule doesn't mean we have to use it. F prime of x equals negative 12x cubed minus 4x. It's a lot easier. So if you're multiplying by a monomial out front, may be easier to distribute. In this next example, I have g of x equals x squared times sine x. Okay. So now my functions are two different things. One's algebraic, one's trig. I have to use the product rule. So two different functions. Have to use it. but it's super easy. G prime of X would be the first function, X squared, times the derivative of the second, cosine X, plus the second function, sine X, times the derivative of the first. And I'd probably just rewrite it like you'd see it, as an answer in a textbook without these parentheses. If I had any negative signs to take care of, I would. I'm also going to take that 2x, because this 2x is really a multiplier, and I'm going to bring it out front. Okay. Because generally speaking, we're always going to see our algebraic portion written as the factor out front. For our next example, g of theta, theta is our variable, equals 3 theta plus theta times sine theta. So now this theta is a variable. We have to use the product rule on that term. G prime of theta equals, what's the derivative of 3 theta? Just plain old 3. Plus, now what's the derivative? This is going to be a product rule, this portion here. I'm actually going to go like this to help us see the two functions. So I have the first, which is just theta, times the derivative of the second, plus the second, times the derivative of the first, and the derivative of theta is just 1. So g prime of theta, if I clean this up a tiny bit, theta cos theta plus sine theta. There's nothing else I can do. That's pretty much simplified as much as possible. Okay. In our next example, I have h of x equals 3x plus 2 times the cosine x. Okay. So here's one function. Here's my other function, right? F times g. First derivative of the second plus the second times the derivative of the first. First derivative of the second plus the second times the derivative of the first. We're going to clean this up. Now, the only thing I can really move is this negative. I'm going to bring that in front of the entire set of parentheses. And I'll take this multiplier and bring that out front. Okay. Remember, everything here, this is one factor, another factor. This negative can just pop right out. If g of x equals x squared of x times that trinomial. Well, first of all, let's rewrite this because I need that radical sign out of the way. And now this is a classic example where you would not use the product rule. Okay, so if you have a monomial with a fraction power, always distribute first. So even though we're learning a rule, we're learning sometimes that it's easier to use our older methods. X to the 1/2 times x squared. When I multiply like bases, I add their powers. So I get x to the 5/2 minus 3 x to the, so x to the 1/2 time, multiply like bases, I add the powers, 1/2 plus 1, 3/2 plus 2x to the 1/2. Now I can apply my rules. 5/2, x to the 5/2 minus 1, 3/2, 9/2, 3/2 minus 1, 1/2 times 2 is 1, -1, -1/2. And if we were asked to, you should be able to rewrite this. So this would be square root of x cubed -9/2 square root of x plus 1 over the square root of x. And that would be the way we would leave that answer. Okay. So I'm going to leave you now. We have some practice problems you can try, and I will see you tomorrow. Thank you.